So guys, as you can see, if when the LED is on, it displays LED on. When the LED is off, it displays LED off. See? On, off, off. Now, if I take you to the code, you will see it's a very simple code. We just initialize the LCD, then we initialize the LCD using a command, then we initialize the LED, then we turned on the LED, then we displayed the LED on the LCD, status of the LED, then we stop the code for 1 second to make sure that the LED is on for 1 second, then we create the screen, and when the LED is turned off, it displays LED turn off on the screen, and then it remains like this for 1 second. After that, again it clears the screen and it keeps on repeating. So this programming gives us this simple result over here. See? Guys, welcome to learning microcontrollers. In this video, I will show you how you can blink an LED with a PIC16F877A microcontroller, and then we will display the status of the LED, either it is in on state or off state, on a 16x2 LM016 LCD. So let's get started. So guys, this is our 16x2 LM016 LCD. It have a port here having 16 pins, 1 to 16 from left to right. If you hold it like this, we have 2 rows. Each row can have like 16 characters, so total of 32 characters at a time. Now let's see how to connect it. This is our PIC16F877A microcontroller having 40 pins. It's a DIP version. This is the 16x2 LM016 LCD. This is the contrast adjustment resistor you needed for the LCD to adjust the contrast. Now guys, let's do the connection. First of all, the potentiometer have 3 pins. It is mentioned on the body as well, 1, 2 and 3. Then for the LCD, we have 16 pins from 1 to 16 from left to right if you hold it like this. Then guys, connect the pin number 1 and 5 of the LCD like this. Send it to the pin number 1 of the potentiometer. From there, you send it to the common ground of your circuit like this. We will power up the whole circuit using the PIC3. So 5 volt from the PIC3 will go to this PIC microcontroller. From there, we will give 5 volt to our potentiometer and the LCD as well. Now the pin number 2 of the LCD is the VDD pin connected to the pin number 3 of the potentiometer. From there, you send it to the VCC pin of your PIC. In this way, 5 volt goes to the potentiometer and the LCD from the same source from which you are powering up the PIC. Now pin number 3 of your LCD is the contrast adjustment pin. You will connect it to the adjustable pin of your potentiometer. In my case, it is the center pin, that is pin 2. Now pin number 4 is the RS pin. For this, you may use any available digital input output pin of your PIC16F877A microcontroller. I'm going to use the pin number D1. For the pin number 6, that is the EN, I'm going to use a D0. Then we will leave the pin number 7, 8, 9 and 10 there for the data pin 0, 2, data pin 0, 1, 2 and 3. We will directly go for the data pin 7, that is pin number 14 of the LCD. I will connect it to the pin number D7, that is port D pin 7 of my PIC microcontroller. For the data pin 6 of the LCD, that is pin number 13 of the LCD, I connect it to the D6 of the PIC. For data pin 5 to the D5, for data pin 4 to the D4 like this. Now 7, 8, 9, 10, just leave them. And for the LCD backlight, we have pin number 15 and 16. You give 5 volt to these pins to turn on the LCD backlight. Else your LCD will work, but there will be no backlight. So 15 is the power. You connect it to the 5 volt, the same which is powering up the LCD, and ground to the ground of the LCD like this. In this way, your LCD will get powered up. 15 to the power, 16 to the ground. Pin number 7, 8 and 9 and 10 are for the 8-bit mode. If you want to use this LCD in the 8-bit mode, while I'm going to use this LCD in the 4-bit mode, so I do not need these pins, so just leave them as it is. Now guys, this is for the LCD. Now there we have our LED, which we are going to blink and then display the status on the LCD. So this LED is a 5mm crystal type LED. To connect it with the PIC, you need a safety resistor. It can be of any value from 100 to as much high. The higher the resistor value, the dimmer the LED will go. So I will use just a 100 ohm resistor. So the longer pin of the LED is the power, the shorter is always the ground. For the longer pin, connect it to the one end of your resistor like this. From the other end, you may send it to any available digital input output pin. I'm going to connect it to the pin number C2 like this, that is pin number 17 of the PIC. For the ground, just connect it to the common ground of the circuit like this. In this way, our circuit is completed. Let me introduce you to the hardware, then we move on to the programming. So guys, this over here is the hardware. This is the LED I'm going to use. This is the LCD. Behind is the PIC16F877A, powered up using a PIC3 power source like this. The rest is just a trainer board, so don't worry about that. Simple circuit, as you can see in the presentation as well, it is the same. This is our MikroC for PIC, so let's start the programming. Let me zoom in so you guys can see better. You may use any version available at your place. So I also have a lecture on this, how to download and install this for free from the official website. Please follow that if you don't have this. Click on File, New Project. New project wizard pops up. Click on Next. Write the name of the project. I write LED status LCD tutorial by LM. Then select the path where your files will be created. Select the microcontroller. I have PIC16F877A. The crystal connected to the pin number 13, 14. I have 16 megahertz external crystal. So I write it here. Click on Next and finish. So guys, this window pops up. Before you do anything else, first of all, click on Save to save your work. Now, first of all, let's initialize the LCD. To initialize the LCD, go to the right in the MikroE libraries, expanded, the system library is expanded. There you have this command called LCD, this. You expand it, there you have this command called LCD and INIT, double click on it. This window pops up. In the example here, you have these commands, you copy them, go back to your programming window, paste it above the void main. Now here the RS pin is defined as B4 while we have defined it as D1. EN is defined as B5 while we have D0. For the D7 of the LCD, it is B3 while we are using D7. Now if you use a different pin configuration, just change these lines. That's all you need. D5 for the data pin 5 and D4 for the data pin 4, like this. Similarly, do this same. That was for the pinout setting, and this is for the pin direction. So RS D1 same as above, D1, D0, then we have D7, D6, D5 and D4, like this. Now guys, to initialize the LCD, again go to the right. Here you have this LCD INIT command, double click on it, and below these commands you have this command called LCD INIT. Copy this only, paste it in the one time loop, like this. Now this command will initialize the LCD with this pinout setting. D1, D0, D7, D6, D5, D4, just verify. Okay, that's perfect. Okay, give some initialization delay. Not necessary, but I always suggest you give it in the one time loop. 100 milliseconds will do fine. So our LCD is initialized. Now we also have a LED connected to the pin number C2, port C, pin 2. So write down trace C.F2 equals to 0. Trace is the direction register, C is the port, F2 is the pin number, 0 means the pin has been declared as output. And now initially I want the LED to be off, port C.F2 equals to 0. Now that is the initial status of the LED, that initially the LED will be off when the code starts. So I just give initialization delay. Now we have the LCD initialized, we have the LED initialized. Let's move on to the forever loop. Write down while 1, forever loop starts here and ends here. Inside it, now start doing the programming. First of all, we need to blink the LED. To blink the LED, initially the LED is off. I copy this, paste it here, so LED turns on. Then LED remains on for like 1 second, and then LED turns off for 1000 seconds. Now we need to display this status, like LED is on and LED is off. So LCD should display on when we are here. When the LED is on, the LCD should display on. So that's what we want to do here. Now for the LCD, there is a command in the right called LCD out. This command, double click on it. This LCD out command, you copy this command in the example here, go back, paste it below this command called this port C.F2 LED turns on. You just start writing from the first row, first column, what it should write, status of the LED on. Okay, so this will display this, and after 1 second, what you want to do is that you paste it here. Now clear the screen. To clear the screen, just send 16 empty spaces, because one row can have 16 spaces. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So the LCD is cleared. Now you just write the second command, that is the off status. Now LED turns off, you write here LED off, just like this. Now again clear the screen for the next command after the delay, like this. So this is the simple code. So it will display LED on when the LED is on for 1 second. It will keep on displaying this, and then it will clear the LCD. After that, it will display LED. It will turn the LED off, and then it will display LED off, and it will display this for 1 second. That's all. Now build this code. No error. That's perfect. It's built successfully. Now open the PIC16 programmer tool. I also have a lecture on this, how to download, install, and use this. If you don't have it, then please go through that. The tool, okay, PIC16F877A is a microcontroller. First you have to select this, like this. Here you go. And then you go to the file, import hex file. This is the file we just created. Double click on it and you have to click on write for the file to be written. Now the file is being written. Just go to the hardware to see what is happening. Okay, you can see the new file is being written. You have to wait. Just wait until the file is being written. Okay, programming device, it is programming. Wait. Okay, once programmed, we will power up the circuit using the PIC16F877A power supply. You have to click this button on. Okay, I power up the circuit using the PIC16F877A programming tools power. I click on. Okay, the circuit is on. Okay. Okay, it says LED on when the LED is on and shows LED off when the LED is off. See, on, off, on, off, on, off. See how perfectly it is working. So this is a very useful application. Like if you are having some motor connected to your circuit, you will use the same technique. Instead of the LED, it will be a motor. If you want the indication of any of your control circuitry to be displayed on the LCD, that is how you do it. So guys, this is it. If you guys learned something from this video, I will be grateful. If you have any questions, you may ask. So we'll see you in the next lecture. So goodbye until then.